All right, we're going to start working on lesson 2.2 today, which is solving one-step equations. We'll be solving these using addition, subtraction, multiplication, or division. I know you guys have done this. I know this is a review, but we still need to go through it and make sure that we're sharp with it and we understand exactly why we're doing what we do. And you'll see that in the last couple of questions, in terms of using some of the properties to justify our process of solving here. Okay, so first of all, some terms just to talk about because we're going to see them. What's it mean to solve an equation? That means you're going to find all the values of the variable that when we substitute it back in makes the equation true. The solution is just that. It's each value that when we plug it back in makes the equation true. And equivalent equations just mean equations that are going to have the same solution. So in the end, they have a variable that is the same as another. Those are considered equivalent equations. All right, so the first property we're going to use today to help us solve is the addition property of equality. And essentially what this is going to say is that if I have a true statement, A equals B, that's true. Then if I add the same value to each side, so I'm going to add C to the left side of the equation, I'm going to add C to the right side. If I add the same value to both sides, this remains equal. I look at it as an equation as a balanced scale. So right now the A and the B are balanced. They're equal to each other. If I add the same amount to the left and the same amount to the right, that scale remains balanced. So that's true. Okay, we're going to use the subtraction property of equality. And basically, if we subtract the number from each side of the equation, the resulting equation is going to be true. So same concept. If I start with A equals B, this is a balanced scale. These two sides are balanced. If I take away C from the left side and I take away that same C from the right side, that equation is going to remain balanced. Okay, so subtracting the same value from each side of the equal sign, each side of the equation, that will maintain its equality. Okay, we're also going to use the multiplication property of equality, and very similar. If we multiply each side of an equation that's already true by the same number, it remains true. So the same kind of setup here. If I know that A equals B, if the left side is equal to the right side, they're balanced. Then if I multiply each side by the same value, the result will remain equal. It will remain balanced. Okay, and then division. Okay, if I divide each side of an equation by the same value, it's going to remain balanced. It's going to remain true. So again, if I start with A equals B, I divide everything on the left side by C. I divide the right side by C. Then if it's balanced to begin with, if I divide both sides by the same number, it remains balanced. Okay, we're going to use these properties to help us solve these one-step equations. When we solve one-step equations, I have a simple process that I go through, and been doing this for years, and this is the best way I know to explain it to you. The first step here is to always simplify each side of the equation and identify the variable term. All right. Now, what I mean by that is we want to add like terms. We want to distribute if necessary. We want to simplify before we dive in and just start adding things to both sides or multiplying and whatnot. Okay. The second step is to isolate the variable term. All right. And I talked about the variable, identifying it up here. Now we want to isolate it. Isolate it means we want to get the variable term on one side of the equation by itself. Okay. So the variable term is the term of the equation that has the variable in it. It could be just a variable itself, or a number times a variable, or the variable divided by a number. It could be a various things, but we got to identify it and we got to isolate it. Typically, to isolate it, we're using the addition or subtraction property of equality. Okay, and we'll see that as we move along. The last thing we have to do is to make the coefficient of that variable term a 1. All right, now coefficient is the number that's multiplied, or the number that's being divided, or the variables being divided by. All right, I got to make it a 1 because I don't want to know what 3x equals. I want to know what x equals. Okay, so here we're going to use the multiplication or division property to make that coefficient become a 1. Okay, so let's put this into action here. Oh, actually, this is a solution process here in which you're going to be asked to identify each step of the process. Okay, what property did we use to do that? Okay, so here are our choices over here at the right. And this is just to kind of tie it all together. We talked about what these properties are. Now let's show how we use them. So if I look at step one, 8 times the quantity of W plus 2 equals negative 32. There's my given equation. Okay. What changed from step one to step two? Well, you took your 8 and distributed it through. So the distributive property was used from step one to step two. Okay. From step two to step three, what are we doing? Well, the difference is I've subtracted 16 from each side of the equation. I'm trying to isolate my variable term, which is the 8W. 8W is a variable term. I subtract 16 from both sides. That's the subtraction property of equality. Okay. Now, from step 3 to 4, what's different? And what we say here is we just simplified it. We did 16 minus 16 is 0, so that left us with 8W on the left. Negative 32 minus 16, remember, is negative 32 plus negative 16. That's negative 48. So we just simplified each side. Okay. From step 4 to 5, what are we showing here? Well, we want to make the coefficient of this variable become a 1, so we're dividing both sides by 8. 8 divided by 8 is 1. That's why we did it. So we're going to use the division property of equality. And then, like I said, 8 divided by 8 is 1, so that's 1W. Negative 48 divided by 8 is negative 6, and that's just simplifying. So this is a little bit more complex of a equation we're going to solve today, but you can still identify the steps. It's still broken into parts that you guys can see and should understand how these steps are used. All right, let's get into solving some of these. Real basic one to start with. Okay, we got G minus 25 equals 113. So if we look at it as its parts, on the left you have two terms. You got G and you got minus 25. On the right side you have one term, it's 113. Okay, we want to get the G term isolated. I want to get G over here on the left by itself. So the way we're going to do that is we're going to add the opposite, or excuse me, we're going to add 25 to both sides. Since it was minus 25, we're going to add 25. And whatever we add to the left, we add to the right. That keeps balance. Now, the reason we did that is because negative 25 plus positive 25 is 0. So we want to get a 0 out of this so that we just have G on the left side, and then 113 and 25 is 138. Okay. Another example here. Now it's got fractions involved, but it's still the same concept. If you look at the equation on the left side, there's two terms, 2/3 plus W. So 2/3 is a term, W is a term. On the right side of the equation, there's just one term, which is that number. Now, our objective always is to get the variable isolated. I want to get this W by itself. That means I got to make this become a 0. How do we do it? We subtract 2/3 from each side. So what you see here, guys, is I did change the order of this, which is called the commutative property. So I made it W plus 2/3 minus 2/3. That right there is going to be a 0. And then on the right side, I did minus 2/3. Okay. So this is going to be a 0. That's why we did it. So we got W equals, and now over here, to actually subtract fractions, you got to get common denominators. So I multiplied here the top and the bottom of this fraction by a 3 to get 9/6. Over here, I multiplied top and bottom by a 2 to get 4/6. And then 9/6 minus 4/6 is 5/6, and there's our answer. So W is 5/6. Okay, I just want to show you this one because of the subtraction sign here. Okay, so you got to understand on the left side, this is really a positive 21, and this is really the opposite of Y. Okay, so if I want to isolate this, okay, I'm going to add Y to both sides. So I'm going to take the opposite of Y and add a positive Y to both sides. Now there's choices on how to do this, and I believe in the other example I'm going to show you. But right now, this will give me a 0. Whatever Y is, it's some number. And it's a negative number, or the opposite of Y, plus the Y, that's going to give me a 0 right here. So I'm going to have 21 equals negative 185 plus Y. Now that Y has got a plus sign in front of it and it's positive, I'm going to isolate it. So I'm going to, I actually flip sides. That's called the symmetric property, guys. The left side and the right side can be interchanged. Now I subtract the 185 because I want to get the Y by itself. So this now is going to become 0. And I get Y equals negative 164. Okay. So that's using all our properties. And the reason, guys, I went back up here and added y is because I didn't want to deal with a negative y, right? I wanted to have it as a positive, so I did it that way. Now, let me show you a different way of doing it, okay? Let's say that I just wanted to leave the y here. Well, what I could have done is taken this 21 and subtracted 21. Now, I would still have minus y right here, okay? But I'm going to make the 21 right here a 0. So I subtract 21 from the right side, right? Subtract 21 from the left. I got to subtract 21 from the right. These two are going together now to give me a 0. And I would have the opposite of y, because that minus sign stays in front, equals negative 164. Excuse me, positive 164. Now, we don't want this to be a negative y. We want it to be a positive y. What we really think of here is that's like a negative 1 times y. Okay, that's the same thing as negative y, is negative 1 times y. And now I want to make this negative 1 become positive 1. So I'm going to multiply it by negative 1. Negative 1 times negative 1 is positive 1. If I multiply the left side by negative 1, I got to go by the right and multiply it by negative 1. Okay, this is going to give me positive 1, and I got y equals negative 164. So you can see it took about the same number of lines of work. I got the same answer in the end, just a little different way of doing it. And there's different ways of doing it. So show your work and show process. Okay, this should say up here multiplication or division, because that's what we're going to use here, not addition, subtraction. But now look at the difference in this problem. Notice that the left side is just one term. It's 3/8 times h. That's a single term. There's not two terms there, there's one. On the right side, there's one term, 9/4. Okay, the point is the variable term is isolated. That's the only thing on the left is this variable term. So now the only job is to make the coefficient, which is 3/8, become a 1. Well, multiply by the reciprocal. 3/8 times 8/3. If you multiply fractions together, you get to cancel top and bottom. So this all cancels out and gives you a 1. And then on the right side, since I'm multiplying, we can do some canceling. So 4 goes into 8 twice. So that's a 2. 3 into 9 3 times. 3 times 2 is 6. So there's our answer. Okay. Okay. Same deal here. The left side of the equation is negative 2 and 4/5 m. That's a single term. On the right side, I have a single term. So now my job is to take this single term and make the coefficient become positive 1. I want to know what 1m is, not negative 2 and 4/5 m. So the first thing I'm going to do is make this an improper fraction. Okay, 2 times 5 is 10, plus 4 is 14. This is negative 14/5 m equals 7/10. So the coefficient is negative 14/5. I want to make it a positive 1. Multiply by the reciprocal. Negative 5/14. This side, negative 5/14. If you look at the left side, the 14s cancel, the 5s cancel. Negative times negative. This is positive 1 right here. On the right side, we can cancel some stuff out, and we're going to get negative 1/4. The positive times a negative is a negative, and then my cross canceling gave me this. Okay. Okay, so those are the one-step equations you're going to work on solving tonight. There is a homework assignment that's attached with it through the ALEKS. Okay, make sure we're getting that completed. Write out your work and show your work. Remember, I'm going to collect all this work before the next quiz. I'm not going to collect it daily. I'm going to collect it all at once. So make sure you're keeping up with the work and you're showing all of the process. All right, I'll let you get at it.